The question is, could you do an example on the calculation of bending stress in a beam? In this example, I will consider a beam with a simple rectangular cross-section. Here's the problem that I have chosen here. You might have seen this in some of the other videos. We have a simply supported beam AB that is subjected to a vertical point load of 10 kilonewton in the middle, like shown in the picture. The beam has a rectangular cross-section like this throughout. The shear and bending moment diagrams for the beam have already been developed. The question is to calculate the maximum bending stress in the beam. The first thing we note by looking at the bending moment diagram is that the maximum value of the bending moment in the beam is 20 kilonewton meter, right? The maximum happens to occur in the middle of the beam, and of course the beam has the same cross-section throughout, right? And therefore it has this rectangular cross-section in the middle as well. Let's try to understand the nature of the bending stress that develops in the beam a little bit. If you recall the sign convention for the internal bending moment, the counterclockwise bending moment on the left side of the free body diagram is taken to be positive, right? Our bending moment diagram told us that we have a positive maximum bending moment in the beam, which is of course 20 kilonewton meter, right? And therefore these are the correct directions for the maximum bending moment. In other words, if I take a small segment of the beam at point C, this is how the bending moment acts at that point. And therefore you can see we're going to have compressive stresses at the top and tensile stresses at the bottom. Furthermore, you recall from the theory video that the normal strain due to bending varies like this, linearly across the cross-section, right? It varies linearly with y, and similarly the bending stress varies linearly with y, right? The maximum compressive bending stress occurs over here, and the maximum tensile bending stress occurs over here. Since we have a rectangular cross-section, the cross-section is symmetric about the z-axis, and therefore these two values are equal to each other in magnitude. We can use the flexure formula to calculate its value. Sigma max equals m times c divided by izz, where m is the bending moment, which of course is going to be the maximum bending moment of 20 kilonewton meter. C is the maximum value of y, which will be half the depth of the beam, or 50 millimeters, right? Izz is the second moment of inertia about the z-axis, right? So we already have a value for the bending moment. We know what C is. Let's go ahead and calculate Izz. Here are my calculations for the maximum bending stress. Maximum bending stress is calculated to be 600 megapascal. First, I calculated the second moment of inertia. You might remember this formula, right? 112 BD cubed for a rectangular cross-section. B is the dimension parallel to the axis. And here this is 20 millimeters or 0.02 meters. And D is the depth, the dimension perpendicular to the axis. So it'll be 0.1 meter, right? So you simplify that, we get a value of 1.667 times 10 to the minus 6 meter to the power of 4 for Izz. Now you plug in the numbers for all three parameters in this equation, and we get a value of 600 megapascal for the maximum bending stress. Once again, remember the maximum tensile bending stress is 600 megapascal, which happens over here. And then the maximum compressive bending stress is also 600 megapascal, which happens over here.